A separately derived system cannot supply power to non-isolated ground receptacles. This is according to the National Electrical Code, specifically Section 384.20. A separately derived system is an electrical source such as a generator, transformer, or solar inverter that is not directly connected to the utility electrical supply. It derives its power independently. Grounding is a critical safety aspect of electrical systems. It provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices, like circuit breakers or fuses, to trip and clear the fault. This prevents electrical shock hazards and minimizes the risk of fire. A non-isolated ground receptacle is a standard electrical outlet where the grounding terminal is directly connected to the building's grounding system. In contrast, an isolated ground receptacle has its grounding terminal isolated from the conduit and other metallic parts of the electrical system. It's connected directly back to the grounding point of the separately derived system. The reason a separately derived system cannot supply power to non-isolated ground receptacles is to prevent multiple ground paths, which can create circulating currents and increase the risk of electrical noise. This noise can interfere with sensitive electronic equipment. When a separately derived system is connected to the building's grounding system through a non-isolated ground receptacle, a ground loop can occur. A ground loop happens when there are multiple paths to ground, creating a loop through which current can flow. This circulating current can cause voltage differences between different grounding points, leading to electrical noise and potential equipment malfunction. Section 384.20 of the NEC addresses the grounding requirements for separately derived systems to ensure electrical safety and minimize the risk of ground loops. The code mandates that the grounding of separately derived systems be done in a specific manner to avoid these issues. Specifically, the grounding electrode conductor for a separately derived system must be connected to the nearest available effectively grounded structural metal member of the structure, or to the nearest available effectively grounded water pipe. Alternatively, it can be connected to other electrodes as permitted or required by sections 250.52 and 250.54. This ensures a single, well-defined ground reference point for the system. When dealing with sensitive electronic equipment, isolated ground receptacles are often used. These receptacles provide a separate, dedicated grounding path back to the source of the separately derived system, minimizing the impact of noise and interference from the building's grounding system. It's important to consult the NEC and other applicable electrical codes when designing and installing electrical systems, particularly those involving separately derived systems. Understanding the grounding requirements is crucial for ensuring electrical safety and preventing equipment damage. Improper grounding can have serious consequences, including electrical shock, fire, and equipment failure. For example, consider a generator supplying power to a remote building. The generator is a separately derived system. To properly ground the system, a grounding electrode conductor must be connected from the generator's neutral point to a ground rod driven into the earth near the generator. This creates a single point of ground reference for the generator and prevents ground loops from forming if non-isolated ground receptacles were used. Furthermore, any metallic conduits or enclosures associated with the generator's wiring must also be bonded to the grounding system to ensure a continuous, low-impedance ground path. It's important to note that the size of the grounding electrode conductor and the ground rod must comply with the requirements of the NEC. These requirements are based on the size of the generators of a current protection device and are designed to ensure that the grounding system can effectively carry fault current back to the source. In addition to the grounding electrode conductor, an equipment grounding conductor must also be run with the circuit conductors to each receptacle and other electrical equipment. This equipment grounding conductor provides a path for fault current to flow back to the source in the event of a ground fault. The equipment grounding conductor must be properly sized and connected to the grounding terminal of each receptacle and equipment enclosure. Understanding the difference between a grounding electrode conductor and an equipment grounding conductor is crucial for proper grounding. The grounding electrode conductor connects the neutral point of the separately derived system to the earth, while the equipment grounding conductor provides a path for fault current to flow back to the source. Both conductors are essential for ensuring electrical safety. In summary, separately derived systems require specific grounding methods to prevent ground loops and ensure electrical safety. Non-isolated ground receptacles cannot be directly supplied from a separately derived system due to the potential for creating multiple ground paths. Consult the NEC and qualified electricians for proper installation and grounding procedures. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to perform the work.